All right, when looking at number 52, there's two main formulas that you want to remember to be able to do this question. The first one is your compounding continuously formula, which is A equals P e to the RT. That is what you're going to use whenever it says that interest is compounded continuously. The other formula we're going to use is your non-continuous compounding formula, which gives you N. N is the number of times that you will compound interest within a given year. And typically, you'll see in problem part A and part B of this question, those are problems that are going to use that second formula. And if you see over here, you see what all the variables represent. N is the number of compoundings per year. R is the rate in decimal. T is the time. And P is the amount that you're putting in. So just setting this up, 4% as a decimal is 0.04. Compounded quarterly is a way to tell you N equals 4. So I know I'm using that second formula. So my A equals the 3,000 I'm putting in. So that's what it said here. 1 plus the rate, 0.04, all over N, which is 4, to the NT power. So 4 times 12. And if you notice I'm putting it in parentheses, that power is in parentheses. That's going to help me later on when I go to plug it in my calculator. So that's something that you might want to be aware of. The next one is 3.9%, which is 0.039 as a decimal. Compounded daily is telling you that you're going to compound 365 times in a year. So the setup for that one looks like this. So 0.039 for my rate over the N to the NT power. Again, T is 12 because you're going for 12 years. All right, setting up the last one, 3.8 is 0.038. Compounded continuously. That tells me I'm using that different formula, the PERT formula. So it's going to be A equals P e to the 0.038 T times 12. So now you see exactly how you're supposed to plug it in the calculator. I'm just going to do A and C just to show you. You can check your answer for part B. So for part A, and you can see I did it before, but this is how you would plug it in. 3,000 times 1 plus 0.04 over 4 to the 4 times 12 power. So rewriting that should give you 4836.68. So 48, 36, and 68 cents would be in the account after 12 years. For the next one, as you can see, I plugged it in already as well. I took 3,000 times e to the 0.038 times 12. Hit enter. You get 47, I missed it, 47.33 and 25 cents. So even though, moral of the story for this problem is even though you get a more compoundings within a year, you're compounding continuously, you see that quarterly with 4% is actually better than continuously with 3.8%. So you want to go for the higher interest rate no matter what way they're compounding it. Interest rate will get you more money. That was number 52. Moving along. Number 59, if you guys are looking at it. The first thing I did, and I showed this step before I did anything, so I could just kind of look at the problem first. But for 59, you have to factor top and bottom of all 4 pieces. So once again, if I could just show you, there are 1, 2, 3, 4 pieces. The first thing I always have students do is to factor this. If you have a calculator program, Alg2CP, that'll do it for you, or you could just do MAF. And it'll get you there that way. So then anyways, once you have it factored, now I'm going to do the dividing. But when I divide, what that requires is you to flip this second term. So this becomes 3x plus 2 times x minus 1 all over 3x plus 2 times 2x minus 3. And it becomes multiplied, and I flip it. So on the top becomes this 2x plus 3, 2x minus 3. And on the bottom, the 2x plus 3 goes along with the x plus 1. So now I see what cancels. And it looks as if, and I could cancel across, so I'm just going to show you. 2x minus 3 cancels with this guy. 2x plus 3 cancels here. 3x plus 2 cancels here. And what I see that I'm left with is an x minus 1 on top and an x plus 1 on bottom. So that would be my final answer. And again, it's all about MAF, factoring, dividing. You flip the second term, and then you cancel out what you can. All right, the next one asks us to add, and again, that starts with looking at the denominators, and if you have the same denominators, you can add them all day. These ones don't have the same denominator, so I got to change them. First things first, though, I got to factor the first denominator, so I'm going to rewrite that. It's going to be x minus 6, x plus 1. X is it? I'm wrong there. Excuse me, x minus 2, x minus 3. All right, so now you look at both denominators. So x minus 2, x minus 3. Again, you could use your MAF or your calculator program that will do that for you. At any rate, you get the denominators here, and you're like, well, the denominators could be the same if the second denominator was to have an x minus 2. So all I do with this is I just add an x minus 2 here, but you can't just add it to the bottom. So you have to add it to the top as well. So that's the process involved. Now, I can take the top plus the top here. I will distribute that 4 in a second. And your denominator becomes x minus 2, x minus 3. All right, at this point, I distribute and simplify, but basically you're just about done. So it's x minus 1 plus 4x minus 8 all over the denominator. All right, which would give me, combining like terms, I get x plus 4x is 5x. Negative 1 minus 8 is negative 9. So the completely correct answer is that one. All right, so that would be how you'd add or subtract two rational expressions that don't have the same denominator. All right, moving on, same chapter. You got this situation where you got three terms, all have different denominators. Well, again, you can set an equation up, or you can do stuff to the problem as long as all the denominators are the same. So what I have to do is I have to think about, like, well, this guy and this guy have the same denominator, but this 5 doesn't. So I need to get that 5 to have the same denominator. So when I rewrite this, I can make 5 have a denominator of the x plus 2 like the other ones. The only trick, though, is that you can't just add it to the bottom, just like we said. If I add it to the bottom, I must also add it to the top. So you can see the thing that I did, the only thing I changed between the first part and the second part was that I added x plus 2 top and bottom to the 5. All right, well, that makes everything on the same level, because now if you were just to multiply both sides by x plus 2, the x plus 2's would cancel. So we just always say if they're all the same, you can cancel them out. So it's x minus 1 equals 5x plus 10 after I distribute. And now here comes a tricky part, because you got that minus 3 minus 2x. You have to distribute the negative inside. So it'd be negative 3 plus 2x. So if you're getting this question wrong, that might be why. At this point, I'm just stuck solving it, okay? So I get 7x plus 7. I add 1. Subtract 7. Cancel. I get negative 6x equals 8. So x equals negative 4/3. All right, and checking if it's extraneous, if a solution is extraneous, so indicate. The only way this would be extraneous is if I plug it in here or here, and I get 0, in which case that value x equals whatever, if it gave you 0, would give you undefined. And if you see, the only value that would make it undefined is if x was negative 2, because anything else is going to be fine. So actually, we're fine. X equals negative 4/3 is the answer. So that's when you check if it's extraneous, if you plug it in the bottom and you get 0. Moving along. Reference angle. Find the reference angle for the following and sketch the angle in standard position. So negative 405. So negative 405, I know that if I'm thinking about the negative angles, that this is 0, this is negative 90, negative 180, and I'm just going to go around backwards. Negative 360, okay? Negative 360 minus 90 would be negative 450. And so I know that my angle is somewhere in here. So negative 405 is somewhere in here. The next question is, what is the reference angle? So like my question for the reference angle is, what is the angle between the x-axis? So once again, it's the angle between the x-axis and the terminal side. And the terminal side is just this side here. So the question is, what is that angle? So I'm saying, well, how far past negative 360 is negative 405? Well, what is negative 405 minus negative 360? If you want to do that, you'll get your answer. One thing you got to remember about reference angles, though, in this case it tells you negative 45. Reference angles are always positive. So the reference angle for this particular case is 45 degrees. And you're in quadrant 4. Okay, so that would be my answer to that one. Reference angles are kind of tricky, always between x-axis and terminal side. Evaluate the following in my calculator. Okay, so for these, you have to keep changing your calculator. These ones are in radians. Radian, here's a degree, here's a degree, and here's a radian. So I'm going to change my mode. I'm going to do the ones that are in radians first, so you can kind of see. So I'm going to use my calculator. My calculator is already in radians. If I look at the mode, it's already in radians for A, B, and E. Okay? So I'm going to put the calculator here and just kind of look at it. So tan of 2 pi over 3. So simply just hit tan 2 pi over 3. Enter. So it's negative 1.732. What did it say? Round 2. Oops. We'll put this down. Round to 4 decimals, so I'll give you 4 decimals for that one. So negative 1.3721. We'll throw it out there. So negative. I think I'll just. So negative 1.7321. All right, tan of 7, simply, again, it's in radians. I know it's radians because there's no degree symbol. So tan of 7 is 0.8714. So 0.8714. And then cotan of 2 pi over 9. Now you're going to say, like, well, how do you do that? I don't have a cotan button. Well, that's just 1 divided by the tan, not sign, of 2 pi over 9. So anytime you see a cotan, secant, or cosecant, you're going to do 1 divided by the trig function that is the reciprocal of that. So in this case, it's 1.11918. 1.1918. Okay? So secant and cosine. So secant of negative 192, secant is the reciprocal of cos. So the secant of negative 192, if we look at that, is 1 over the cos of negative 192. Before I hit enter, I'm gonna make sure my mode is changed to degrees, because now you're talking about degrees. So that's the only trick to these ones, is making sure your calculator's in the right mode. So it's negative 1.0223. So negative 1.0223. And then lastly, I could do cos of 300. Cos of 300 actually is a nice number. It's a measure that we know exactly. In this case, it'll be 1/2. Okay, so again, change your calculator to radians if it's in radians, degrees if it's in degrees, and if you're doing a reciprocal, like you did here, again, what I plugged in was 1 over the cos, and this one I typed in 1 over the tan. All right? All right, next one, solve the equation between 90 and 180. So the first question is, what quadrant is that? And from experience, I know that's quadrant 2. If you're not sure why that's quadrant 2, look at your unit circle and make sure that you know any angle between 90 and 180 has got to be in quadrant 2. So the tan theta being negative 2.5. So what I do in my calculator is I do second tan of negative 2.5. All right, and that'll give me an angle. Again, I want my mode to be degrees, which is kind of fortunate that I left it in degrees from the last problem. So negative 68. So you're like, okay, that gave me an angle, but it didn't give me an angle in the second quadrant. Okay, the easiest way to find that angle in the second quadrant is to take this. So I kind of know, you're like, I know the negative 68 is somewhere down here. And I know that I'm looking for an angle with that same reference angle in the second quadrant. So negative 68, so that's a reference angle of positive 68. So I'm looking for something that's got a reference angle of 68 point whatever in the second quadrant. And that's the trick to this problem. So I'm going to take 180 minus 68.19 or 68.2. All right, so my answer would be 111.8. So that angle, again, it's between 90 and 180. It's in the second quadrant. And the tan of 111.8 would equal negative 2.5. And just to check it, you could do tan, just to check, tan of 111.8. You should get something close to negative 2.5. It's really close, because actually I rounded, so you know it's not going to be exact. All right, the other problem would be the same way, except sine is negative in the third and the fourth quadrants. So again, decide what quadrant you're looking in. That's the third quadrant. So in my calculator, I do second sine of negative 0.25, and that'll give me an angle in the fourth quadrant. So I want my angle to have that same reference angle in the third. So I'm going to take 180 plus 14.5. If you're like, why'd you take 180 plus? Because I want an angle in the third quadrant, and I know it's got to be bigger than 180. So I'm going to take an angle that's got a reference angle of 14.5. So the angle is 194.5 degrees. And once again, if you want to check it, take the sine of 194.5, you should get negative 0.25. So, I mean, we can take that real quick. So the sine of 194.5, it should be pretty darn close to 0.25. It's negative 0.25, and it is. All right. Moving along. I'm going to do a couple of one of these. Just find one positive and one negative coterminal. So when I'm finding coterminal, you know it's basically the same angle. Okay, if it's in degrees, then I'm going to add or subtract 360. If I'm looking for coterminal in radians, then I'm adding or subtracting 2 pi. So we'll do one of each. So like for 420, for instance, 420 minus 360 gives me one positive coterminal. So 420 minus 360 gives me 60. So I'm going to take one positive coterminal. I'm going to minus 360 again. Okay, that'll give me my negative. So 60 minus 360 is negative 300. So there's one positive and one negative. Going to part D, we could look at radians. So 17 pi over 6 minus 2 pi. All right. In your calculator, you could do this. This is the way we did it in class. But if I do 17 over 6 minus 2 pi, I just don't touch pi. And I know that there's pi attached to this. So 5 pi over 6 minus 2 pi. Again, now don't touch pi. Negative 7 pi over 6. So I see 5 pi over 6 and negative 7 pi over 6. Again, when you put it in your calc, just don't touch pi. All right. Next, to solve the trigonometric equation for theta, where theta is 0 and 360. So tan of x equals root 3. All right, I know that happens 2 times. So I know excuse me, that the tan of x equals root 3. The tan is positive in the first quadrant. All right, and I know it's also positive in the third quadrant. So I'm looking for 2 angles. One will be between 0 and 90, and the other will be between 180 and 270. Okay, so the question becomes, where are these angles? All right, so the first one I could just do second tan, just like we did before. Second tan of root 3. So second tan of square root 3. And that'll give me my one angle, which is 60. Well, that's pretty nice. So that's this angle in the first quadrant. So out of the 2 angles I'm looking for, I got one angle that's 60. The other angle is in the third quadrant with a reference angle of 60. So to find that, yeah, you just add it to 180. So 180 plus 60 is going to give you an angle in the third quadrant bigger than 180. That's be 240. So your 2 angles that give you a tan of root 3 are 60 degrees and 240 degrees. If you needed them in radians, change them to radians. Pi over 3 and then 4 pi over 3. Okay, next question. Find the distance across the lake. This is a cosines question. Okay, I know that this is little c, this is little a, and this is big B. So now it's like if I had a log cosines question where you said big B equals 80 degrees, little a equals 160, and little b equals 140, you'd simply be like, oh, that's log cosines. I'm going to do c squared, and not c squared. I said it wrong. Little c equals 140, my bad. So I would do b squared equals a squared plus c squared minus 2ac cosine, move this over, cosine of b. Cos of b, cos is 80. This is b. So then in my calculator, I type all this in, and I take the square root. All right. From there, see if you can get the right answer. I set it up for you. You can take it to the next step. And the last one I'm going to do is number 4. It says sketch one full period labeling the x and y axis. Okay, so amplitude is 1. All right, it's always the absolute value of the number in front of the trig function. Max and min are 1 and negative 1. I know that because there's no vertical shifts. The period is going to be the part that's going to trip you up. Again, the period is 2 pi divided by b. b is the number in front of the x. So in this particular case, b is a half. So then the period is going to be 2 pi divided by a half. So in my calculator, if you don't know how to divide 2 by a half, you go ahead and just divide 2. Don't touch pi in this case. In this case, it'd be 4. So now I know that the period would be 4 pi. Okay? When I sketch a sine graph, I know I want to sketch one full period. So I know that 1, 2, 3, and my 4th tick mark is going to be my period. So I know that that's going to be 4 pi. Okay, the other thing is, like, what are these other tick marks? What is the amplitude? We already know the amplitude is 1. Okay? And I got to figure out what these other tick marks are. So that is called your x scale. And the x scale is found by taking your period, which is 4 pi in this case, and dividing it by 4. Always divide by 4 because there's 4 major sections of the graph. So the period divided by 4 in this case is really easy. 4 pi divided by 4 is pi. So then each one of these tick marks is going to be pi. So this one's going to be 1 pi, this one's going to be 2 pi, and that one's going to be 3 pi. So you just go up pi each time, just like if you were counting, be up 1 each time. 1, 2, 3, 4. And that's not what I'm doing here. I'm going to go up pi. Pi, 2 pi, 3 pi, 4 pi. So I got my scale set. I got my y-axis set with the correct amplitude. And now I'm going to graph a negative cos graph. So the question is, where do I start? Do I start here, here, or here? Okay? And that's the trick. Since it's a negative cos graph, cos graph starts either up or down. It's going to start down. So it's going to start down at -1, and then it just follows the same pattern. Okay? As far as this graph is concerned, I didn't have my students do a lot of tables with this stuff. If your teacher did, you could fill a table and fill in those points. But for this particular graph, it follows the same pattern each time. Hopefully this helped you, and hopefully you're ready to do well on this final.